Hello there, Mr. Sutton here with the IM3 Honors 7-8 Part 1 homework solutions on writing equations for trig graphs with midline and phase shifts. For number 1, we're going to write an equation for this curve, and I'm going to start with the sine version of the equation, and then we'll use the cosine version. So using our little sine setup here, let's pick out the amplitude. That's half the height. We have a height going from 0 to 4, so half of that is going to be 2. And then we need the b value. For that, we need first the period. So to go from the top to the top here, that's a horizontal distance of 1, 2, 3, 4. Period of 4, we're going to do 2 pi divided by that for the b value. So that's going to be pi over 2 for this b value. For the horizontal shift, if we're looking for sine, well, sine starts at the middle of the wave going up. That's right here. So let's see, that's over 3 for the h value. And then for the k value, that's the midline of the graph. That's the average of the top and the bottom. That's going to be 2. So plugging it all in, we've got 2 sine of pi over 2, parentheses, x minus 3, close parentheses, plus 2. And now for the cosine version of all that, everything's going to be the same, period, amplitude, b value, except for the h value. Cosine starts at the top of the wave, and this one's actually easier to do with cosine because the top of the wave here is actually right on the y-axis at the x value, 0. So we have an h value of 0 then. K value is still 2. I'm plugging all that in, and we've now got 2 cosine pi over 2 x, because we don't need to put minus 0, and then plus 2 out there. To write an equation for number 2, let's start by getting our amplitude. This curve is going between -3 and +3. So that's a half the height of 6 is going to give us an amplitude of 3. And I'll use sine first. We'll do sine first, then cosine. So amplitude will be 3. Period on this one. Well, I can see that we're going from, let's see, pi over 6 to 7 pi over 6 if I'm doing middle of the wave going up. There's other places I might be able to look, but that's the one where they gave us the best grid lines. So let's see, 7 pi over 6 minus pi over 6, that's 6 pi over 6, which is just pi. So period is pi. B value then is going to be 2 pi over pi, which is 2. For the h value, based off of the sine curve, middle going up happens at pi over 6, and also 7 pi over 6, but why make our lives difficult? I'm just going to use this first one here, so pi over 6 for h. For the k value, this is centered on the x-axis, so our midline is just going to be y equals 0. Plugging that all in, we're going to have y equals 3 sine of 2, and then x minus pi over 6 in parentheses. Outside there we've got plus 0, which we're just not going to bother writing. So there we are. Now, to do this graph with cosine, using this formula, I've still got an amplitude of 3. I've still got a period of pi and b value of 2. The h value is going to change, though. Cosine, the top of the wave, happens on this one at 5 pi over 12, so that's our new h value. Midline is still 0. So the equation's pretty much the same, except now instead of sine, I have cosine, and instead of x minus pi over 6, I've got x minus 5 pi over 12. To write an equation for this one using the sine function, I need my amplitude. So we're going from 1 to 3. That's a height of 2. So half of that is 1 for the amplitude. For a period, let's see, if I go from top of the wave here to top of the wave over here, that's 1, 2, 3, 4, 5, 6 for the period. And then 2 pi over 6 gives us a b value of pi over 3. For the h value for sine, middle going up, there's 2 places this happens. The earliest one is this -1 over here. Actually, it's not quite -1. It's pretty close to -1, but that's not quite middle going up. Middle going up is going to be halfway between the bottom and the top of the wave. So halfway between -2 and +1 is going to be -1/2, so -0.5. And then another place it happens is over here halfway between 4 and 7, so 5.5. So either of those. K value is going to be 2 if you average the 1 and the 3 for the top and the bottom. Plugging all this in, we've got 1 sine, which we're not going to write, so just sine of, let's see, pi over 3, x plus 1/2, all of that plus 2. And now if I go over to this page and do everything with cosine, I've still got the same amplitude of 1, same period of 6, and b value of pi over 3. The h value is going to change. For cosine, this is a lot easier actually. Top of the wave happens at 1, so you can use 1 for the h value. You also could use 7 over here, either of those. And then midline is still 2, so our formula, our function is still pretty much the same, except now we've got cosine instead of sine, and now in here we've got x minus 1. Everything else is the same though. For writing an equation for this one, using sine, I've got an amplitude of, well, let's see here. We have a height of 4, so half of that's an amplitude of 2. And then for my period, I can go from, let's see, 0 to 4 pi, and I'm going from bottom to bottom of the wave. So we have a period of 4 pi. 2 pi over that gives us a b value of 8. For my h value, middle of the wave going up, that's what I'm looking for if I'm doing sine. So let's see, the earliest place that happens is right here. This is halfway between 0 and, let's see, this must be halfway between 0 and pi over 4. So this is pi over 8 right here. Halfway between 0 and pi over 8 is going to be pi over 16. So that one's kind of tricky to pick out, but you could reason it out if you know that these are going in regular intervals here. For the k value, the midline, halfway between 1 and 5, I've got a midline of 3. If I average those, I'm plugging it all in. We've got y equals 2 sine of 8, parentheses, x minus pi over 16, all of that plus 3. If I want to do everything with my cosine function now, well, I've still got the amplitude and the period and the b value are all the same, but now the h value, cosine, we're looking for the top of the wave, so we could use pi over 8, and then the k value is still 3, so plugging all that in, I've now got cosine here, x minus pi over 8 here, plus 3. If you wanted to make your life even easier, you could use negative cosine with an h value of pi over 4, or actually just an h value of 0. That'd probably be the easiest thing to do on this. To get an equation for this interesting looking graph, looks like they took a picture of someone's graphing calculator there. I'm going to do a version for you in both sine and cosine, but you only really need one of these. And there's an infinite number of possible answers, but here's 2 of them. So if we're doing sine, I'll start with the formula a sine of bx minus h plus k. And I'll go ahead and find a, b, h, and k and just plug them in this. So for a, that's the amplitude. That's half the height. So I need to find the height and then divide it by 2. To get the height, I just do top y value minus bottom y value. So we've got 4 minus negative 1. So that's really plus 1. So that's a total distance of 5. And all of that divided by 2. 5 over 2, we're just going to call 5/2. No need to really go any further than that. It's a fully reduced fraction. For the b value, I need to find the period, the p, and then divide that. I divide 2 pi by whatever that period is. So how long does it take for this wave to repeat? Well, we're at the bottom of the wave on the y-axis here. And the next bottom is over here at pi. So that's actually a period of pi, which is kind of convenient. Because now when I turn around and do 2 pi divided by the period, 2 pi over pi, those pi's neatly cancel, leaving me with just 2. Next, to get the k value, the midline of the graph, I need to average the top and bottom values to find that middle y value. So I'll pretty much set this up like the amplitude, only I'll do 4 plus negative 1 over 2, which gives me 3 over 2. And just looking at this visually, 3 over 2 is about 1.5, so that's right here, which does look to be the middle, vertically speaking. Okay, for the h value, that's going to depend on the trig function that I'm using. Since I'm using sine, and sine starts at the middle of the wave going up, I need to find middle going up on here, And then whatever x value that happens at, that's going to be this h in here. So taking a look, the first middle going up I see is right here. And if you're not sure exactly what x value that is, it's going to be halfway between the bottom and the top of the wave's x values. So halfway between 0 and pi over 2 is going to be pi over 4. It's exactly what it looks like there. So putting it all together, I've got y equals my amplitude of 5/2 times the sine of my b value, which is 2 we discovered, times x minus the h value pi over 4, plus the k value of 3/2. Now, I'm going to do a cosine version of this as well, and to do that, I'm going to keep my amplitude, my period, my b value, and my k value. None of that's going to change when I change the trig function to cosine instead of sine. So most of this will be the same. What's going to change is this h value. Cosine the wave, we always like to start at the top going down for graphing a cosine function. So the first top of the wave that I see on here is right here at pi over 2. So that's going to be the h value if we go with cosine instead of sine. So plugging all that in, we still have an amplitude of 5/2. We still have cosine this time, but we still have 2 for the b value. Now we've got x minus pi over 2, and we still have the k value of positive 3/2. To write the equation for this graph, we're going to start by picking a trig function, either sine or cosine. I'll use sine just to start, but then I'll show the cosine answer. So here's my general sine formula. 8 times the sine of b times x minus h plus k. So I need to find a, b, h, and k. For a, the amplitude, that's going to be half the height. So we have top minus bottom for the height. That's 3 minus -5, so 3 plus 5. And we're taking half of that, so that's going to give us 4. For the b value, I need to take the period and do 2 pi divided by the period. So it's kind of hard to tell the period because the grid lines don't match up great on this. But if I take a look at this spot on the origin right here, I find the same spot on the wave right about here at pi over 2. So I can pretty confidently say that my period is pi over 2 on this one. And then 2 pi divided by pi over 2. Same change flip. That's really 2 pi times 2 over pi. Pi's cancel, leaving me with 2 times 2, or 4. Now for the h value, I need to find the the x value, where I have the middle of my wave going up, because that's where sine likes to start. And taking a look here, I appear to have that right here at pi over 4, half a grid line, pi over 4. So my k value, that's going to be the average of the top and the bottom, the midline. So it's kind of like the amplitude, only we'll be doing 3 plus -5 instead of 3 minus -5, and then dividing that by 2. -2 over 2 is going to give me -1. Plugging it all in, we've got y equals the a value of 4 times the b value, or sine of the b value 4. We have x minus pi over 4, all of that -1 for the k value. And now I'm going to go ahead and do the same thing for the cosine version of this formula. Everything's going to be the same, except you'll notice the h value needs to change. So now I need the x value for the top of the wave. And there's lots of candidates here, lots of tops of waves that we can see. I'm just going to pick the first one, which is half a grid line before the y-axis. So that's going to be -pi over 8, because the grid lines are going by pi over 4s. And then plugging all that in, we have still 4 for the amplitude, cosine of 4, x minus -pi over 8, so x plus pi over 8, all of that -1.